Hello, welcome to lesson 7.4, properties of triangles. Today we're going to talk about two types of triangles, both similar and congruent. Similar objects have the same shape, but not necessarily the same size. For example, a tennis ball is similar to a basketball. A model ship is like an actual ship, or the two are said to be similar. Our properties of similar triangles. For similar triangles, the ratio of corresponding sides is going to be equal or congruent. The ratio of the corresponding heights is going to be equal to the ratio of the corresponding sides. The measure of the corresponding angles are going to be congruent. For the first example, we're going to use similar triangles to find an unknown height of a triangle. It says triangles ABC and DEF are similar. We're going to find the height FG in the triangle DEF. So in each of these, our height is going to be outside of our triangle because of the way the triangle is sitting. Go ahead and label each of my triangles. Again, I suggest you draw them on your paper. All right, so as we're looking at these, the height of triangle ABC is 4 centimeters, and we're trying to find the height of triangle DEF, which is side FG. So I'm going to put an X right there. So as we're setting these up, we want to pay attention to the orientation. Notice that both of these triangles are sitting pretty much the same way. I don't need to rotate them so that their orientation is the same. This side is going to represent the base, and this side is going to represent the base. This side represents the height, and this side represents the height. There is more than one way to set these up. I'm going to show you my favorite way. If you end up going to the tutoring center, they may show you a different way, and that's okay too. I like to do the little triangle over the big triangle. So I'm going to start with what I need to find. I need the height. So I'm going to do the little triangle over the big one. So 4 centimeters over X. I'm going to set that equal to, again, little triangle over big. I'm going to use the bases, 8 centimeters over 12 centimeters. Again, my setup needs to be the same orientation and the same pieces. So height, base, base, little over big, little over big. To solve, I'm then going to do a cross multiply. And then I'm going to divide. So as we are doing this, pay attention to the two numbers that are across. They're the ones you're going to multiply. The one that is across from the variable, that's the number we're going to divide by. So 4 times 12 is 48. And 48 divided by 8 is 6. So my unknown height is 6 centimeters. The triangles are not always going to be turned so that the orientation is the same. In some cases, you're going to have to redraw it or figure out which pieces are in the same location. This next example will show you what I mean by that. All right, in this figure, it says angles B and D are right angles. AB is 12 meters. DC is 4 meters. AC is 18 meters. And we're looking for the length of CO. So again, I'm just going to redraw this, just like if I were drawing it on my paper, like you're going to do. And then label each piece. So D, C, O, this is B, and this is A. So B and D are right angles. So I'm going to put in the little box to show a right angle. AB is 12 meters. DC is 4 meters. And then AC is 18 meters. Well, AC represents this whole distance. AC equals 18 meters. Well, I need this 18 to be the small triangle and the big. So we're going to use some algebra to help us rewrite these distances. O to C is in the little triangle. I'm going to let that be X. Now, just to help you think about it, what if X were 2? If the whole distance is 18 and OC were 2, then I would have 16 left for AO. If X were 5 and the whole AC is 18, I would have 13 left for AO. In any case, in order to find AO, I take 18 minus whatever X is. So we're going to label AO as 18 minus X. And I'm going to go ahead and draw in this little distance measurement thing so that it shows that it is the distance from A to O that is 18 minus X. X then is going to represent the distance from O to C. Together, they're going to add up to 18, whatever those distances are. So notice that my right triangle is up here and down here. When we talked about orientation before, this is what I'm talking about. The DC measurement and the 12 meters measurement, those are going to be in the same orientation. If I were to turn this little triangle or flip it down, they would both be the bases of the triangle. And this side, AO and OC, would be my hypotenuse of each triangle. So again, in a right triangle, the distance across from the right angle has a special name, and it is hypotenuse. The other two sides are called legs. The base is usually what's on the bottom. So in this case, the 12 and 4 are in the same orientation. So again, if I do little over big as my setup, I'm going to do the hypotenuse first. The little triangle is X. The big triangle is 18 minus X. If I do the bases next, the little triangle is 4 meters. And the large triangle is 12 meters. Now I have to do a little extra work this time, but that's okay. The process is going to be the same. I'm still going to cross multiply, but I can't just divide. I'm going to have an extra step. So let's go ahead and set it up. 4 meters times 18 minus X. So I'm going to write that with a parenthesis. is going to be equal to 12 meters times x, or 12x. So notice I have a number outside of my parentheses. So hopefully you remember from basic algebra that then I need to distribute the 4 to both. So 4 times 18 is 72. 4 times x is going to end up being minus 4x because the sign stays with the number. And that's equal to 12x. We're just going to solve for x. So we're going to do 2 steps, add 4x to both sides. And then we're going to have 72 equals 16x. And we're going to divide both sides by 16. So x is going to be 4.5 meters. That's going to represent the length of CO, which is what we were asked to find. If we wanted to find AO, we would then take 18 minus 4.5. They didn't ask us to do that in this problem, but we could just as easily. Again, keep in mind that both OC and AO have to add up to 18, is why we set it up this way. The second part of today's lesson is congruent triangles. 2 triangles are congruent if they have the same shape and same size. The corresponding angles of congruent triangles have the same measure, and the corresponding sides are also congruent. So hopefully, as you look at these 2 triangles, you'll notice that they both have a side that's 7 centimeters, both have one that's 8, and both have one that's 5. All 3 sides have the same measure. There are different ways that we're going to say that we can prove that the triangles are congruent. We're going to use side theorem. If 3 sides of one triangle are equal in measure to the corresponding 3 sides of a second triangle, then the 2 triangles are congruent. Side angle side theorem. If 2 sides and the included angle of one triangle are equal in measure to 2 sides and the included angle of the second triangle, the triangles are congruent. Or angle side angle. If 2 angles and the included side of one triangle are equal, then the measure of 2 angles and the included side of a second triangle, then the 2 triangles are congruent. I want to talk specifically about the last 2. Side is pretty black and white. If all 3 sides are the same, the 2 triangles are congruent. For side angle side, it is important to note that the angle that we are talking about has to be between the 2 sides that we know. For angle side angle, again, the side that we're talking about has to be between the 2 angles that we know. The word included means between. Okay. So let's try a problem and you will see what I'm talking about. So for example 3, I have 2 examples. Says, determine whether the 2 triangles are congruent. If we say they're congruent, then we have to say why. And our 3 choices are side, side, angle, side with the angle between the two sides, angle, side, angle with the side between the two angles. So those are the only ways we can say the two triangles are congruent. So when you look at the first set, the first triangle shows that we have a 45-degree, an 80-degree, and 55-degree angle. And then the second triangle shows that we have a 55-degree angle, an 80-degree angle, and a 45-degree angle. These would not be congruent because there is not an AAA option. Knowing all three angle measures does not prove that the triangles are congruent. Let's look at the second set. We are told this side 18 and this side 16. Well, this triangle has an 18 and a 16. And then the angle between those two sides is 60 degrees in both. So yes, these are congruent. And the reason is side, angle, side. The last part of this lesson is going to be the Pythagorean theorem. Hopefully that's something you've heard of before. The Pythagorean theorem is only used with right triangles, and the formula is a squared plus b squared equals c squared. What's important to note is that c is always going to be the hypotenuse. We talked about this a few minutes ago. The hypotenuse is the side opposite the right angle. A and B then are called legs of our triangle. So our problem says, determine the length of the unknown side of a right triangle. The leg of one leg of the right triangle is 8 inches. So that's the side that's labeled. The hypotenuse is 12 inches. Again, that side is labeled. And it says, find the length of the other leg. So I'm going to make that X. Round to the nearest hundredth of an inch. So again, a squared plus b squared equals c squared. And c has to be the hypotenuse, which is the side across from the right angle. The other two sides, it doesn't matter which one's A and which one's B. So I'm going to make this one A and this one B. We're then going to fill in the values that we are given into our formula and solve for our unknown. So a squared, 8 squared. B squared, I'm just going to make it be x squared for my distance. And c squared will be 12 squared. Remember, when we square a number, we're taking it times itself. So 8 squared would be 64. 12 squared, 144. To solve for x, we're going to subtract 64 from both sides. And then to solve for x at this time, we're going to take the square root of both sides. So 8.9442791. We're rounding to the nearest hundredth of an inch, so 2 decimal places. The number after isn't 5 or higher. So side B, or x in this case, is going to be 8.94 inches. Again, make sure as you're plugging in numbers that C always is the hypotenuse. In some cases, you may be asked to find C. In other cases, you may be asked to find A or B. The process is the same, and I look forward to seeing you next time. Again, don't forget about those extra practice problems in the ebook on the Cengage WebAssign website. Click on ebook and go to chapter 7, and you can go right to some extra practice. Again, the odd ones do have the answers, and I suggest that you do a few more of these than just the homework that's required. Thank you and have a great night.